Okay, so before we can really take a closer look at this idea of instantaneous rate of change and tangent lines and their slope and yada yada yada, we have to review limits. We're going to take a step back, review those, and then we can plunge back forward again. So this idea of limits, we've done limits, but it still isn't locked in, and that's okay, but let's see if we can get a few more ideas figured out. So first of all, limits they tell us how a function will behave at a certain point. Even if the function does not exist at that point. Which is a weird idea. How can a function do something if it doesn't actually exist? And that's what limits are helpful for. So we've seen how to write limits, right? We have the lim, x approaches some number, right? Will behave at a certain point. X is getting closer and closer to that certain point. And then it tells us what is the function gonna do, right? Because we're talking about a specific function, so we better make sure we include that function. Now, a lot of ways to tackle limits. I'm gonna show you two that are probably gonna be the most helpful for you. So, how can we evaluate limits? So the first way and the easiest way and the way I like the best, and I think the way a lot of you would like the best, is we can just plug in x. If I've got a function and I've got a number, let me just put that number in there, right? Make my life a little easier. When we do this, chances are one of three things will happen. The first possibility is the result that we get when we plug in x. The result will be a real number. In other words, we'll start with a number, we'll end with a number, and we'll be happy. Now, if we get a real number, chances are, the majority of the time, that will be the limit we want. If it's not, we're not going to worry about it for right now. That'll be something you guys can dive deeper into in calc. Second option. You might end up with some number dividing by 0. The only wrinkle is that it can't be 0 divided by 0. If this happens, chances are you've hit on an asymptote. Right, you've probably hit on an asymptote somehow if you've gotten to this point and you end up dividing by 0. The third option is we get 0 divided by 0. And when we get 0 divided by 0, our next step, we just gotta try something else. It's kind of a hot mess. We wanna look at how can we simplify the function. So, do we need to factor it? Do we need to rationalize it? What do we need to do? Now, what I'm telling you is this third option, this try something else, we're not going to deal with that right now. We're going to be working with limits where most of the time we can just plug it in. Okay? But that's one way to evaluate limits. The other way to evaluate limits is to read a graph. So, we need a graph. talk about 3 key places in this particular graph. Okay, not a continuous graph, but that's okay. We are going to look at 6 limits. And so the first round of limits we're going to look at is dealing with this 3. In other words, we want to look at how the function is going to behave at 3. So let's look at, as x approaches 3, from the left. So that little negative means that we are approaching from the left. So from the left looks like this. I'm coming from the left. And as I do that, for this function f of x, I get, let's see, what's my y value? 1, 2, 3. Okay? If I look at the limit as x approaches 3 from the right, coming from the Owatonna side of the graph, or from the east of this function, well, then I'm only at 1, which means that the limit as x approaches 3 does not exist. Which is kind of a bummer. But the 2 sides didn't agree. The function doesn't meet at 3. It's discontinuous. Okay? Let's do another one. Limit as x approaches 5, 6, 7 from the left. So here's 7. I'm going to come at it from the left. Equals 3. If I come at 7, let's do a couple things. Let's slide that up a little bit. Let's change this. We already did 3. If I come at 7 from the right, once again, it's 3. And since they agree, the left-hand limit and the right-hand limit, since both limits match, then we can actually say what our limit is. So just quick clarification, that little negative means from the left. And the plus means from the right. Which is what we had up here. So very quick review of limits. You do a little practice with it. I know you'll get it figured out. You're rock stars.